going to ask, or at least make the statement, you should be asking me, what does it mean A equals 1? You keep saying that, but what does that mean?
I'm recording.
Okay.
I'll send it to you later.
All right.
Okay.
Sounds good.
Blue sky.
What's that? Yeah, so Holden, we're going to be quiet, right?
Yeah, Holden.
Thank you.
Yeah. Carson, you better not.
Okay, so what does A equals 1 mean? So we need to go back a little bit, and we need to talk about the standard form of a quadratic. So this right here, ax squared plus bx plus c, and eventually it'll be equals 0. But for right now, just as an expression, this is what the standard form of a quadratic looks like. You know how we did like y equals mx plus b? That was the normal graphing form of a linear equation. I don't know if you were ever taught what standard form of a linear equation was. Do you know what standard form of a linear equation was? Okay, so standard form of a linear equation was ax plus by equals c. This was standard form of linear equations. And these are the ones that you solved with the elimination method were always written in standard form. So that's standard form of a linear. This is standard form of a quadratic. And when I say A equals 1, what we're referring to is the coefficient of the x squared is equal to 1. So A equals 1. These are going to be known as the easy ones to factor. Because when A is 1, there's a lot less possibilities for what it's going to be. Now, an example of something like this would be like x squared minus 5x plus 6. Okay, so this is standard form quadratic where A is equal to 1, meaning the number in front of x squared is 1. And tomorrow I'm going to get into the ones where A is not equal to 1, and those are a lot more challenging and a lot more involved. Okay, but for right now, what I want you to see is this great little shortcut for factoring these. How many of you know about diamond problems? You remember the diamond problems like this? Yeah. You remember those? We've done those a little bit, where you multiply to get the top and you add to get the bottom.
Yeah.
Okay?
No.
So, like if we had a 6 here and a negative 5 here, do you think you could solve that diamond problem for me?
Yeah.
Raise your hand, solve it for me. Maddie, what do you got? Negative 2 times? Negative 2 times negative 3. Good. Because negative 2 times negative 3 is positive 6. Negative 2 plus negative 3 is negative 5.
Facts.
That is actually the whole reason they even... Hold it. Okay, the whole reason they even taught you about diamond problems was so that you could begin the process of factoring quadratics. It's the only reason they even teach them. See, if you can factor, if you can solve the diamond, you can factor the quadratics where A equals 1. So we just did it. All you have to do is write x minus 2 times x minus 3. Those are the factors. Now, you might be wondering why, Mr. Thompson. Okay, why are those the factors? Well, let me show you. This negative 5x, right? That was a combination of something, right? It was, if you look at these over here, that middle term, I don't know if that's on the screen there, but that middle term came from these two being added together, right? So if you multiply this back like here, so x times x is x squared, right? And then x times minus 3 is minus 3x. Negative 2 times x is negative 2x. And negative 2 times negative 3 is positive 6. Look at what we have here, okay? So, this negative 5 comes from adding these two together, right? So what we were looking for when we factor is we're looking for two numbers that when you multiply them together, you get the plus 6. And when you add them together, they come out to that -5 in the middle.
Oh.
So let me do another one, and it'll hopefully make some sense here. So on this one, you don't even have to write the diamond if you don't want to. But what we're looking for is, see, when we do these factors, we know that when we multiply them back together, the first part of it's got to give us x squared. And what times what is x squared? X times x. So when we're trying to figure out what did we multiply to get that, we already know that x times x was x squared, right? We should know that x times x is x squared. Okay, so that's how this is going to begin. Then what we're looking for is, well, we need something that's going to multiply to 3. In this case, it's pretty easy, right? It's going to be 3 times 1. So if I have this in here, because you know how we're doing, when we're doing all the distributive property stuff up here, when we're multiplying the first two together, we get x times x is x squared, right? And where does that 6 come from? It comes from the last two multiplied together. So right now, if I'm looking at this, I know that this will give me the x squared, and I know that this will give me 3. And that's the beginning and the end. The real mystery is how do we get the 4? So this one's a pretty simple one though, because there's not a lot of possibilities. The only way, yes?
How did you know it was 1 times 3?
Well, what are factors of 3? What do you know that multiplies together to make 3?
3 and 1. 1,
Yeah.
1 and 3.
And 2.
Okay, good point. All of these, so 1.5 times 2, right?
Mm-hmm.
So all of these though are going to be integers. There's not going to be any fractions or decimals when we factor, okay? So all of these are going to be integers. So you're only looking for integer factors. And so since 3 always comes from a multiplication and 4 always comes from an addition, that's where they came up with that whole diamond thing with what two numbers multiply to get the one on the top and add to get the one on the bottom. So I'm going to explain more about it tomorrow because it gets a little more complicated. But we got x plus 1 and x plus 3. Here's the other thing too. Well, let me do the diamond problem. By the way, I'm not going to draw this whole diamond thing every time.
Just learn.
Okay? I'm not going to draw this diamond every time because it just takes too long. So I'm just going to do an X for a diamond from now on. I'm going to do a lot of diamonds. And
Wait, are we
so
supposed to do
the
that?
number that goes on the
Yeah.
top,
Oh.
technically, up here is
Come on,
A
take notes. I
times
like to
C.
listen.
So remember, if I put ax squared plus bx plus c, the number that goes up there is going to be a times c. And since today a is always 1, it always just ends up being c, because 1 times 3 is just 3. So, and the number that goes on the bottom is b. So when we do our diamond, for this one, it's going to be 3 on the top, 4 on the bottom. And all we're trying to think about is, okay, what multiplies to 3 and adds to 4? Well, not a lot of choices. It's 3 and 1. And they're both positive, so we write them both as positives. I'm going to do more and more and more because the more I do, the more it'll hopefully make sense. So let's try another one. Let's take one that's very similar. Actually, I'll put it over next to it, to this one here. X squared. I'm going to have a minus 3 out here instead. Okay, and then I'm going to have a minus 2x in the middle. So let's take a look at what this one could be. So we know it's going to be x times x to get x squared. And we know to multiply to get 3, we need 1 times 3. The thing we're trying to figure out is which of those is going to be the negative and which one's going to be the positive. I can't have them both negatives. How come? Because -1 times -3 would be a positive 3, but that's a negative. So one of those has to be a negative and one of them's got to be a positive. So that's what you're trying to figure out. And the little diamond can help you, right? If you put a -3 here and a negative 2 here, you can think, okay, multiplies to negative 3, adds to negative 2. And hopefully you come up with negative 3 and positive 1, right? So that means the 3 is going to be the negative and the 1 is going to be the positive. And those are your factors. Now, we're really new to this, so we ought to check, right? Make sure we're doing this right. So that's x times x is x squared. X times minus 3 is minus 3x. 1 times x is plus 1x. And that's minus 3. Do those two combine in the middle to make the minus 2x? Yes, they do. So that means we did it right. Okay, let's keep going. A couple more. Actually, let's go up to your worksheet. We'll do a few off of your worksheet now.
Oh, yes.
So let's go up to this one.
Wait.
Factor and quadratics worksheet.
Yeah. I'm probably going to do all of them.
Wait, hold on.
Wait,
They should go really fast once you get the hang of them.
there's no
okay?
math. You haven't.
It's right there.
Did I published it right?
Where? Oh, wait, found it.
Yep.
There's a YouTube video. Oh, it's Khan Academy.
Okay, so we've got b squared plus 8b plus 7. So a lot of people do it this way, where they like to put their diamond right underneath, and then they'll have the factors down below. But the more you do these, the less you even need the diamond, and you just think in your head, okay? Because 7's gonna go on the top, 8's gonna go on the bottom, and all you gotta do is think, okay, multiplies to 7, adds to 8. And that's just gonna be 1 and 7 or 7 and 1. It doesn't matter what order you put them in.
Oh.
So this would be b plus 1 times b plus 7. Yeah?
Does it matter what side the B and the 1's on? I mean the 7 or the 1's on?
No. Not in, since both of these are just a single b, it doesn't matter. Tomorrow, when we're gonna have numbers in front of b,
Oh, you missed
then it will matter, okay? But for right now, it doesn't matter.
No doubt.
No doubt.
All right, this is a good one because it's not one that you just instantly think of, but we know it's going to be m times n. And then what we're trying to do is think of what multiplies to negative 90 and adds to positive 1. What multiplies to negative 90 adds to 1.
How do you know which to put at the bottom of the diamond and the top of the diamond?
So, yeah, so I gave you that little code. So A times C goes at the top, and then B goes at the bottom. So if you have an A, a B, and a C for your standard form, you do 1 times 7 goes in the top, 7, and then 8 goes on the bottom.
Oh,
Does
okay.
that make sense?
Yeah.
Okay.
Yeah.
So, anybody figure it out?
You're gonna get it
Multiplies
right.
to negative 90,
Wait. Negative
adds
90.
to 1. Lucas, what do you got?
Oh, yeah.
Negative 9 and 10.
Negative 9, positive 10, and it doesn't matter
Why
which
is it
order
10?
you do it in.
What?
There it is. Those are the factors.
Negative 9 plus 10 is
Okay.
I'm focusing.
So, look,
Shut explain.
if you want to check your work, just
Oh,
to be
got
sure,
it.
okay, and tomorrow, well, not tomorrow, on Thursday, we're really going to be checking our work. But
You're not going to be here tomorrow?
I am going to be here tomorrow. I'm going to teach you a whole nother method tomorrow, though.
Is
And then-
this one the easier or harder?
This is the easiest. This is as easy as it gets right here.
What about
Just-
yesterday?
Great.
Yesterday was pretty easy.
Great.
Okay, yesterday was the easiest. Today's just a little step up. Tomorrow and the next day are probably the hardest thing we're going to do.
Ever.
Oh,
Maybe ever.
oh my god.
Ever?
Maybe
Oh, no.
ever this year.
Oh.
This
Okay?
is
Not ever in your life. Okay? If the hardest thing you ever do in your life is Wednesday and Thursday in my class, you are going to lead a very charmed life.
Yes.
I hope
Because life better get harder than that for you. All right. So,
Arm.
so how do we check this? So first off, this is the beginnings of what's going to be known in the future as the guess and
They won't
check
use this
method.
video, you know that, right?
But when we do this, you already know
I
that
believe.
You
m
believe?
times m is m squared. You already know that, right? So we don't need to check that part of the distributive property. And you already know that 10 times negative 9 is negative 90. You never would have guessed that in the first place if it wasn't, right? So you don't need to check that. The only thing we're checking is, did we come up with this plus m? Did we come up with this plus m correctly?
Yeah.
Okay, because if we had the plus sign on the wrong side, it wouldn't be correct. So how do we check that? Well, that's by multiplying these two and these two. Those are the ones that check to see. So m times negative 9 is negative 9m, and 10 times m 10 is 10m.
Yeah.
Does that add to 1m?
Yeah.
Yes.
Okay, so that means we did it right. So
All me. I'm gonna try this problem.
10 times negative 9 is 9.
10.
all right, let's see here. Let's skip to maybe, oh, this is a good one right now. Not right. I think we're ready for that one. Let's do 7 and then I'll do 8 with you.
Wait, how do
Okay.
you check again? Can you go back real quick?
Yeah,
No.
how do you check? You just
You
multiply. You guys remember yesterday when I mentioned
Be
FOIL?
quiet.
Like your parents learned FOIL and it stands for first.
You don't tell me what to do.
Excuse me, guys. The F stand for first. Okay, the O standed for outer. The I stood for inner. Okay, and the L stood for last. So when you're multiplying these, you got first, outer, inner, last. When you're doing the distributive property in that order. Okay, to do the check, you just need the OI part of the FOIL, the outer and the inner. So you just need to check this one. That's the negative 9 and the negative 9m and the 10 times m, which is the 10m. That's how you do your check. I'm going to explain this in great detail on Thursday, how to check, because we're going to be working with the more challenging ones like this. Like this one working backwards to this has tons more possibilities. Think of all the different ways you could multiply to get 6x squared, right? So you've got 6x times x and 3x times 2x. And then that would have to combine with all the different ways to get negative 20. So there'd be like negative 4 times 5, or negative 5 times 4, negative 10 times 2, or negative 2 times 10. Okay? 20 times negative 1, or negative 20 times positive 1. And all those would be different combinations that could possibly go with the ways to multiply to get 6x squared. And so there's just a lot more possibilities than just what we're working with today. So it gets more complicated tomorrow and Thursday, and that's where we're headed. But it's good that you're understanding how to do the check right now. All right,
My video.
I'm gonna work on number 7 with you here, okay?
Wait.
And if you like the diamond, let's do the diamond. You don't have to if you can just start to think what multiplies to negative 24 and adds to 2. So if you can, you got it? What'd you come up with, Al? What is it? Negative 4, positive 6, that's correct. So that means our factors are m minus 4 times m plus 6. Those are our factors.
Oh.
Do we have to do the diamond?
You don't have to do the diamond. That's what I'm saying. If you can just see it by looking at these, you can just write it. That's fine. Okay, so this one's a little bit different. That's why I want to go over this one.
Main op.
Okay, multiplies to 24, adds to negative 4. Let's write it out just so we can think about it for a minute.
How does that work?
Well, we know it's got to be a negative times a negative. That's the only way to multiply to get a positive and add to get a negative, right? So we got to think, well, what do we know that multiplies to 24? Well, 24 and 1,
6 and 4.
6 and 4, 8 and 3, 2 and 12. Are any of those going to add to 4?
No.
No, so we have encountered our first unfactorable quadratic.
Uh-oh.
So you just write not factorable.
Facts.
That's it. So if you can't solve the diamond, it is not factorable. I mean, that's assuming that you're,
I think this one
Got some
might
diamond
also be
skills.
non-factorable.
and not everybody is. So if there's nothing that solves this diamond, then it is not factorable.
I need a multiplication chart.
Now,
The Siri is.
I want to scroll down to the second page because this is where
Oh my god.
it gets a little bit
The second
Oh
page.
dicey.
my god.
2 pages.
The second page.
Yes, there are 2 pages.
No.
Wait, are they? Oh.
What happened with 15
Why did you
here?
make this 2 times longer than it needs to be?
Wait. I don't make it seem- Do we have to check them?
Gosh darn it.
2n squared instead of just n squared.
Yeah,
Yes,
I thought,
Robert.
Mr. Thompson, I thought you said we were just dealing with A equals 1.
You liar.
Almost. Almost. Okay, here's the deal. What do you notice about 2, 6, and 108? What do they all have in common?
I don't know. I can't check.
They are all,
Oh,
I heard
I thought you
it
meant
in a
that.
lot of, like,
I'm gonna end it.
mumbling.
They're all numbers.
They're all divisible by 2. They're all even numbers. So,
Wait.
listen please, on all of these today, where A doesn't happen to be equal to 1, here's what you're gonna do. It's called
No, you don't.
factoring out a common factor. So, just take a 2 out of this, like reversing the distributive property and rewriting it so that it's n squared plus 3n minus 54. Now, this is a quadratic where A is equal to 1. And on this one, we're going to do the diamond where you get negative 54, positive 3.
Sucks.
And so multiplies to negative 54, adds to 3.
20.
Look for 2 numbers there, Holden. Good thing you got that front row. All right. Okay, thank you. It's 9 and
It's my
negative
red
6.
dog. My
If
red
you
dog.
if you multiply those
red
together, you
dogs.
get negative 54. If you add them together, you get positive
Is that
3.
Ben 10?
So when I go to write these factors here, I have to include the 2. 2 is one of the factors. So 2 is a factor, and then we'll have n plus 9 and
She
n
doesn't
minus
own
6.
socks.
I
Okay.
don't know. I feel like she doesn't. I can find the thing.
That's a little weird.
Yeah.
Watch them play that and they hear about how Charlotte
He doesn't wear socks.
Okay, so hold on.
Does she
Ricky
wear
just asked a question.
She only wears them
Why
occasionally.
do we need to know this? Well,
Yeah.
this is just the beginnings of a huge part of your math life. Okay? So this factoring is going to be very
That's a B.
common. I missed it, so but we've got it on
Yeah, we got it on camera.
on video, so we can make sure we get that taken care
Oh
of.
yeah.
Um,
You're
I'm
getting
gonna get
a
a
B,
lot
buddy.
more of these.
Okay, so we are going to use this in a process that we're going to start to solve quadratics. And this is how we're going to start to solve them. Okay?
Bad word.
So
But you're threatening
this
me.
is just
Nobody
a
cares.
skill that we're learning so that when we get to solving we can do that. Quadratics are a very common equation in life. Gravity follows a quadratic. If you throw a
I'm
ball,
not gonna
it
use-
follows a parabolic curve, and quadratics are parabolas. So
Why am
there's
I
a
gonna
lots
try to-
of practical application to quadratics. Anyway,
Yeah.
I'm still a little confused.
so if we do this one
You
here,
just said if you're
I'm
gonna
just
try
gonna
to
do
find
one more
where
and
the
then I'm
ball
gonna be
drops,
done.
That's the line.
okay? So
Grow up.
take out the 5, we'll have v squared minus
I gotta buy
6v
Alright.
plus 8,
Girl, what?
It's so greasy.
okay?
No, it's not.
And
It's so.
so that'll be
delicious.
v minus, well actually
Stop.
I'm going too
Stop.
fast. I'll let you guys figure it out. It's getting a little wild in the front row here. So, can anybody figure out what
It's a
multiplies
mosh pit in here.
to 8
Yeah.
and adds to negative 6?
It's spicy.
And there you go. Those are the factors.
We don't have to check it, do we?
No, I mean, if you know you did it right, you don't really have to check it. We're going to go over all the answers tomorrow. Yeah.
So if you put that in the order, like do we say -2?
So kind of confused.
Yeah.
Huh?
These two are, today, they're
Oh,
interchangeable.
yeah, and then we're gonna
Okay.
have some.
Yeah, probably.
Don't you keep the square?
Don't mess
Stop.
with me.
Okay. Hold on, guys. I can't hear the question. What?
Your feet are in my way.
No.
I shut the camera off.
Hold it. So, the question is, don't we keep the v squared or the squared? Well, we do at
My
this
muzzle.
point, But what we're trying to do is we're trying to factor that v squared minus 6v plus 8. And so we're trying to figure out what multiplies to give us that. And then the v times the v is the v squared. Okay?
Okay.
All right. You guys, why don't you spend the rest of the time kind of working on this worksheet, asking for help as you're trying to get it figured out.
I'll send you